Welcome to the Tesseract podcast, where we unlock your power to innovate. I'm Chloe.
And I'm Dan, and we're your co-hosts. Our mission is to empower airmen, connect them to resources, and accelerate change across the Air Force logistics enterprise. Today we're joined by Mr. Roberto Guerrero, Deputy Assistant Secretary of the Air Force for Operational Energy. With over 30 years of experience in both military and civil service, he leads efforts to optimize how the Air Force powers global operations, ensuring energy efficiency enhances mission readiness and resilience. A former E-3 Sentry commander and seasoned aviator, Mr. Guerrero's expertise spans aviation, safety, and strategic energy innovation. Thank you for joining us today, sir.
Yeah, my pleasure. Thank you for the offer. Yeah.
Absolutely. Can you tell us a little bit about yourself, your career, and kind of what led you to your current role?
Sure. Parents came from South America in 1957. I was born in 62 in Los Angeles. My dad was always interested in aviation and engineering. He was actually a self-taught engineer. I guess you could do that back then, right? And so, as a young kid, model airplanes and whatnot, and knew I wanted to be involved in that, and as well to become a pilot. So I picked a school, California Poly, that has an aero engineering degree. To go to school, spent several years there. I actually worked as a student intern at Vandenberg when it was Vandenberg Air Force Base, and now it's Space Force Base, but worked as a student intern for a couple of years. Saw Top Gun 1 and said, I'm going to the Navy to be a pilot. So finished up finished up college, went off to flight school, and then first duty assignment after flight school was flying the Huey helicopters, actually, in Antarctica. We used to deploy down there once a year. I did that 3 times for like 4 to 5 months at a time, supporting the National Science Foundation. So not your typical Navy career or Navy job. Then transitioned to a warfare specialty with helicopter mine countermeasures. So that was in San Francisco, California. And then they moved the whole squadron down to Corpus Christi, and that's when I became a fixed-wing instructor pilot. So I was flying the T-34, getting a lot of hours there. That was a lot of fun. And was trying to decide what I was going to do next. And there's this thing called inter-service transfer that isn't used very much, but at the time it was used a fair amount, partly because the Air Force was losing a lot of pilots to the airlines. So they transitioned a bunch of us. I went from Lieutenant Commander Guerrero one day to Major Guerrero the next day without any so there was a time there where, when I became a squadron commander, the joke was that I would use terms that they would go, what? I'd say, well, it's over there on the deck and they're like, what's the deck? Ladder well for stairs or scuttlebutt for the drinking fountain. Anyways, long story short, my nickname as a squadron commander there in the E-3 was Skipper because of that, right? Mm-hmm. So went up to Tinker, learned how to become an E-3 pilot, and became aircraft commander, and then went out to Okinawa and did that. Came back to the States and stopped at the Air Force Safety Center, where I was chief of space safety. And a little bit of what I did at Vandenberg was space safety, so I knew that part. Chief of ground safety. Then I was the vice commander of the Air Force Safety Center, and then became an SES. And stayed there as the executive director of the Air Force Safety Center and did that for a couple of years. In my previous time, both in the Air Force, but predominantly in the Navy, as a Navy officer, you typically will work in maintenance. So I was the quality assurance officer for the H-53s and the Hueys. And that really gave me a perspective that I think sometimes Air Force pilots don't have because they don't work in maintenance and they don't understand the challenges. So that was helpful to me, as well as I served in each squadron. I was the safety officer on multiple safety mishap investigations. And kind of what I learned from that and what brought me to this job via the Director of Staff Air Force Reserve Command, which was my second SES job. What brought me to this job was, reducing mishaps is a lot like increasing efficiency because it really is process-based as well as technology-based. Like when you break it down to the bare essentials, how do you reduce, let's say, motor vehicle mishaps? Well, first off, you have anti-lock brakes. To protect the passenger, you have seatbelts and airbags. You have like these sensors that'll keep you from hitting somebody, and then you have driver's training, right? You have to have both, right? And that's a lot of the way we attack efficiency in the Air Force and try to maximize lethality per gallon by thinking about technologies that aren't being used right now that make our aircraft fly farther, make the engines perform longer, those type of things, as well as, training, operators on good practices in order to, extend our miles per gallon, so to speak.
Okay.
Awesome. So, well, yeah, I mean, it's really an incredible career thus far, right?
I mean, pretty lucky.
Yeah, absolutely. Yeah. It sounds like it. I had the opportunity when I was in Hawaii, stationed out there, to team up with a retired 4-star general who owned a T6, a 1944
nice.
T6. And so I used to, on the weekends, go out, or at night, go out there and, wrench on that aircraft, and then fly it every once in a while, right up the West Coast into the North Shore. And but going from that to my day job, which was working on C-17s, it was night and day, right?
Sure.
And being able to, I think I had a unique perspective when I went back to my normal job, because I was like, it was very easy just to see how far aviation had come, right? From checklists on a 1944 trainer aircraft to the C-17, and the technologies we were using that keep that aircraft in the air, right?
Yep.
And monitor systems that, pilots don't even have to worry about, because the aircraft regulates itself. But to bring it, full circle, that it was just very interesting from your safety perspective to see how much more confident and safe the pilots were and could be, right? And to fly their mission when they weren't having to worry about every little factor of the aircraft while it was flying.
Sure.
Right. And so, I've always been curious, and I'd love to learn more as maybe we move through the podcast of, kind of how safety has played a role in your development of your career.
Absolutely. Yeah.
Mm-hmm. Absolutely. Great story, sir. Also loved the cued in on Antarctica, and just what a different world to be a part of.
Yeah, it wasn't the real Navy, but it was a great tour. It was just, whales, killer whales. I've got a picture of a killer whale in my office that I'm on, like a little ice floe, and it's swimming right past me, and then the baby of that killer whale actually bumped into the ice, and that whole piece that I was standing on calved into the water. And I'm like, man, maybe I could stay a little farther away from the crack. But yeah, it was fun. It was definitely fun.
Absolutely. Some very unique experiences. So cool. So, sir, as you talked a little bit there, you talked, towards the end about the current position that you're in. And in AFI 90-1702, operational energy is defined as the energy that's required for training, for moving, and for sustaining military forces and weapons platforms for military operations. So the Air Force program focuses specifically on aviation assets and aerospace ground equipment that support them. That's a lot of words there. So can you kind of help break that down for us and explain why having a dedicated office for these efforts is so crucial?
So first off, just going back to the reason for an OE office, why it was stood up, and then kind of making some relationships. When you go back to like the early days of aviation, there weren't safety offices, right? We all know that that's kind of the standard thing now. Everyone's trained in safety. What does it do for us? It keeps our people from getting accidentally hurt. It keeps our assets from getting damaged and increases combat air power, right? So we think that's core to our mission, and it's been core to our mission for decades, right? So if you think about it in the same way, really during like 2007, 2008 timeframe in Iraq and Afghanistan, we saw pretty large increase in casualties that were logisticians delivering fuel and water to outposts. And part of it was, how do we protect those logisticians? You see those lines of fuel trucks and other things on fire. And so the Secretary of Defense said, hey, we need to understand this challenge better. We need to understand how to protect those folks better, because if 1/3 of our casualties in this theater are just from logistics operations, then how do we protect those folks better? And how do we reduce the number of times that they have to make deliveries? And so that's when they started looking at the tooth and saying, hey, we have forward operating bases that are getting equipment that's not properly sized for what their requirement is. It was typically oversized, so it would use too much fuel and too much water. So this whole thought process behind like logistics risk came into being, and they stood up an office first at the Secretary of Defense. There was a assistant secretary for operational energy, and then each one of the services stood up their own offices for operational energy. And initially, at the time, it was much more relevant, at least for that theater, for the Navy, or excuse me, for the Army and the Marine Corps, because they were doing the majority of those logistics trains, logistics deliveries to the forward operating bases. So as we got involved, we started looking at, well, how is this going to affect us in the next theater? When you think of distances between bases, for example, like let's say Bagram to Al Udeid, which is a big air refueling base, 1,200 miles or so. Like Hawaii to Guam is like 3,500 miles, right? And so the distances that we're going to have to be dealing with in the Pacific are so much bigger than what we were dealing with in the last war. So that's going to require a mindset change for us, right? And to understand how much more important that fuel delivery is going to be, how much more difficult it's going to be, and therefore, what are we doing to address the processes and the technology so that that our assets make it to the battlefield, they don't run out of fuel, and that's really why the Operational Energy Office was stood up. And so we've taken it down a couple of paths. We have folks who look specifically at fuel logistics supply chain risk. So we have our Chief Master Sergeant Zigstad, who's now Mr. Zigstad, is my chief for that particular office, and he plays in war games. What we found out early on was that we would participate in war games, and we'd say, "Who's tracking the fuel usage?" And they're like, "I thought you were." Right? It was that type of thing where we really weren't thinking about fuel as being not only an enabler but a critical risk for us. And then we have other offices that look at technologies. And we have another office that looks specifically at, the operators. How do we talk to the operators about the importance of understanding that what they're burning out the tailpipes of their aircraft is not free? And if we optimize that, then we're not spending as much money in our budget on that, and we can spend it on other things that we need to protect our warfighters and to advance combat capability.
That's really interesting, sir, as you talk about that. I think when first thinking about fuel and fuel efficiency, it's easy to jump to financial purposes behind that. But I think that was really helpful in understanding that the inception of it was a life and death of the personnel on the ground delivering the fuel, sure. And that is going to be a problem that we're going to see again, like you're saying, in the future theater.
Right.
And that is really the core tenet, it sounds like, behind the imperative, not just the financial.
Correct. Aspect. To me, it's the bottom line is about how do we address this fuel supply chain risk that we know we're going to have? Because we play out these war games, we run out of fuel. What are we buying to make sure that we're not going to run out of fuel? Because the fuel can be easily targetable. It's not easy to hide those big tanks, fuel tanks in Guam, right? So we know that the enemy is going to target those type of things. What are we doing to decrease our risk by making sure that we're more resilient on the ground and we're more efficient in the air, so that when the fighter needs gas, the tanker is there and it has the gas to give.
Absolutely, yes. And when you spoke a little bit about the war gaming, right, and going to that room and saying, who's tracking fuel, I've had many of those same conversations in tabletop war game sessions where at what rate are you resupplying your arms, right? Are how many bombs are you bringing in compared to what you're expending, right? And they say, oh, well, we just, assume that they're there. Right. Mm-hmm. Well, okay. Well, let's have a conversation about the thousands of miles and multiple sorties it took to get them there, right? And then how do we make that more efficient? Yep. It is some conversations I've had in just the past 2 years since I've been here at Tesseract, and it's definitely been eye-opening. And I completely understand from their perspective, right? While they wouldn't think of that, because there are so many things to think about from the point of, I have supplies here, I need to use them, right? Right. And so, I think it's extremely important that I guess we're thinking about that kind of stuff, right? Exactly. And so, and we try to convey all that information out to our airmen in the field, in the logistics and maintenance career fields. That hey, here are some important topics to think about. Yep.
And in the past war, our logistics supply chains weren't targeted, at least on the aviation side, weren't targeted. We never really worried as much about the munitions being there, about the fuel being there. It was just kind of an assumption that it was always going to be there. And so it's tough to make that or to change that habit pattern and thought process that, hey, it's going to be different in the Pacific. And so we need to start planning for that battle. I watch this movie every once in a while. It's called Moneyball, right? And Moneyball is about the folks who are doing sabermetrics and understanding, this different way of going at, the game by using data analysis that really wasn't used beforehand. And you see, the arguments between the general manager saying, hey, we need to think differently here. And the old hat, scouts who had been scouting baseball for years and years and years and having their opinions, and really the difficulty in getting folks to think differently. And that's really what you all are trying to do, and that's what we're trying to do. We're trying to get folks to think differently because, the only countries and militaries that continue to succeed are the ones that adapt to change and that are willing to change to address the next challenge that they're going to have in the battlefield. So,
absolutely. Yeah, and Tesseract's mission centers around fostering a culture of innovation within logistics and maintenance. Can you explain why innovations in operational energy are so important, and maybe talk about a couple of your successes within logistics and maybe sustainment? Yeah,
the first one that we went after that really was pretty successful. Turns out one of the he was a lieutenant colonel at the time. He went to be the maintenance group commander at the 58th SAO, but he was working at the safety center beforehand. So I knew him. We had a relationship, and we had learned about the issues that the CV-22 community was having, particularly in their engines. In New Mexico, there's a lot of challenge for operating those kind of aircraft there, with respect to the particulate matter that can be ingested by the engine during brownout landings and whatnot. And so they were getting very little life, on the order of just a few hundred hours on their engines. And so we had met this company at Purdue. So a lot of what we did early on was we were traveling to like United and Delta and American and FedEx, but we were also going to the research centers like Purdue, Georgia Tech, and others to learn about what new things were coming out in aircraft sustainment that we could maybe take advantage of. And there's one company that was doing this engine wash. They're called AeroCore. They're on contract with us right now. And we proposed that, hey, maybe AeroCore could help out with the CV-22 engine washes. And what we didn't realize at the time, and sometimes folks are specifically thinking that we care about just the fuel burn. And this was a pretty good example of that we weren't, and that you really cannot, there has to be some level of incentivization in what we're doing for folks to participate, right? And so in this case, what we found is that the status quo engine wash required all the cowlings to be pulled off of both engines. So you could think of a CV-22 when it's on the ramp, it's got its nacelles up, and the rotors are up. And so the way they would wash it is they would have to pull the cowlings off of both sides. They would actually pull out these little plugs that I have here that were in the side of the burner, so in the turbine section, the hot section. And you can see how, for this particular example, that's a brand new one, and this one is the one they tried pulling out, right? Oh, yeah. So the first challenge for these folks was that after pulling the cowlings off, now we had to go ahead and pull that particular plug out to put the detergent nozzle to get detergent into the hot section. And it more often than not broke, and then they had to call on a tech rep, and things stopped for a while, and the aircraft was down. Not good for anybody, right? So we were pretty happy with going in and saying, we think there's a solution that doesn't require you to do that. And this solution was this nucleated foam process, where they were actually combining like detergent and water, but a really, really small amount of detergent, the same kind of detergent you typically used. So there wasn't any concerns about, hey, you're bringing in different chemicals that we're not comfortable with compressed air, and it would actually foam into the engine. So they hit the starter switch, it foam into the engine. It covered the whole engine, not just the hot section. And now all of a sudden you were addressing just particulate matter throughout the engine, not just in the hot section, as well as corrosion issues and other things that the CV-22 was experiencing. And then we also did some auditing of, the water source that was going into the legacy wash system, and that wasn't as pure as it could have been. So there were a lot of factors that said, hey, we're not helping these engines out by washing them in the legacy way that we're doing it. We have this other way that not only is better for the engine, but it was actually much, much less maintenance manpower. So, my buddy at 58 South, he was like, yeah, absolutely. If you guys want to pay for that, we're all in. Why? Because now I don't have to have two folks working an engine wash for the whole day when I can get the engine wash done in an hour and get the aircraft back on the ramp and get it flying again. The other thing we saw is that there was a pretty noticeable increase in available power to the crews, so the engines didn't go bad as quickly. And now this isn't, I would say, I can't attribute it to just us, but they replaced about half the number of engines than they had replaced in the previous year, and they attributed some of it to the fact that, hey, we're taking better care of our engines now, so they're lasting longer. So now, and they showed me the second time I visited there, they go, hey, here's our sheet, and look how many FMC aircraft we have now as comparison to last time, right? So that got us thinking, what other ways can we work on the sustainment piece, because it helps, provide us more combat air power. The number of aircraft that we have in the Pacific to fly combat missions is going to be based off of, how many crews we have, but how well our maintenance is in getting those aircraft up and green and ready to fight the next day. So that's, for us, we think that was a pretty neat thing. And then we spent some time with Delta Airlines, especially Delta Tech Ops, their turbine engine division, on looking at other things, because they were the ones that initially had confirmed our thoughts on this one nucleated foam. They said, hey, the other things we're looking at is, compressor blades that are wearing out quicker. So we think we know of this one company that does these coatings that will allow the compressor blades to last, keep their shape much longer. So for us, it's less fuel burn because the engine is performing like it was when it was brand new for a longer period of time. But then that engine is going to last that much longer, so there's less maintenance required on it, so we can concentrate on other stuff to get green aircraft, right? So it's those type of things that we found that, and we've had some really good success with PEO propulsion, Mr. Sneeden and his folks in working these things, because we are, in fact, saving some gas money on these things that we could talk about later, but we found a way to recoup that money so it doesn't go back to the Treasury on the 1st of October. As well as it's allowing us to get after challenges that he's having in his power plants that he couldn't get after before. So again, there's that incentive there. He wants to work with us because we can bring in money to help, sustain engines better than he could in the past with the money that he was getting. And it's all based off of his participation, results in greater, recoupment of funds at the end of the year, which turns into more things that we can fund to help them.
That's incredible. And the only thing I could think of when you were talking about these plugs, the hot end plugs breaking, were that it would definitely happen on a swing shift on a Friday, right? That's the only time it would definitely happen, right?
Exactly.
And firsthand experience, I noticed down out at Hickam how much the salt water can affect engines, right? And how much we had our bird bath go down for a period of time, and how much that affected corrosion in our engines, and how we changed 14 and 12 months, right? And that's
right.
But on top of that, downrange, right? And in the context of great power competition, maintaining aircraft is, in a contested environment, is always a struggle, right? We are going to have maintenance to do on the ground. There's no question about that. How can we reduce that maintenance burden down to tasks that are critical and not maintaining engines that we should be mitigating maintenance on in advance, right? And so in a contested environment, the kind of work that you and your office in collaboration with the propulsion office are doing now could realistically save lives downrange, right? And that's,
to me, some of it is about, like, we're not delivering aircraft downrange that we can pull the data and already recognize that they need something to be done before they go downrange. So part of this whole engine wash program is a separate data collection program that we've been working on, funny enough, from the safety center, where we're able to pull some of the data that they use for safety data before it goes into the official safety system. We can take, flight recorder data, and we're in the process of helping ensure that we can actually track the performance of the engines based off this engine wash process, so we know the right time to do the work on them. We've also thought about, okay, what other things can we help out with? For example, like the airlines are starting to get pretty good at understanding, those, and as well as the Air Force A4 is getting pretty good at understanding what the situation is with respect to parts. Like if we're sending something downrange, or sending it to a location, do we know if that aircraft has something that's coming up, time wise that could maybe fail earlier than we expected, and is there parts nearby that we could get? There's those kind of things that we really haven't been able to energize in the past as much as we'd like, and we're really starting to do it, and it's exciting. And for us, a lot of it has been learning along with Delta. Like the engine wash, they confirmed it. The coatings, they confirmed it on their aircraft. So we know it works, and we just have to figure out which technologies work the best for us for our mission, because our mission is going to be a little bit different than theirs.
Absolutely. Yeah, and before we move on, I wanted to talk a little bit about how you really kind of harped on the importance of the collaboration you had with the propulsion PEO, right? We find a lot when working with different program offices how, I guess you could say, task saturated they are, right? They have a lot of problems that they're trying to solve. And that's not to say that the Air Force has a lot of problems. It's just we work in a space where there is always something to do, right? There is always a problem to solve. And there's always something new that you're learning about while you're doing it, right? And so, in the 2 years I've been here, we've really explored how much we can enable program offices to, continue on the path that they're on, solving problems, but then in parallel, solve the problems that are after that with airman innovation, right? And there's airmen out there in the field that have the capabilities to, design and test and do a lot of these different steps. And we've really been exploring that, and I've been starting to see that collaboration happen, not just, in the innovation ecosystem, but between offices across the Air Force, right? And I just, kind of wanted to harp on that again, because I think it's been a really cool evolution of just communication throughout the Air Force as we try to, prepare ourselves for a different type of great power competition.
I agree, and I sometimes relate it to, so when I was a squadron commander, I had a limited TDY budget, and there were just some things that, at that time I was just like, that's a brick wall for me. I'm not going to make any more money, print any more money. So this is all the money I have. And so when I would hit that brick wall, I'd stop. Okay, we're going to stop training. We're going to stop traveling because we're out of TDY money. And I think there are a lot of times where program offices are in the same boat, where they have all these tasks to do and they only have so much resources to do it with. And so when we initially would approach them on things that we had ideas for, they were like, that's great, but I just don't have the money and manpower. And so we started thinking through, how do we fix that? And so we approached Congress and we said, look, we see that you have this section 2912 in the NDAA, and in that section it talks specifically about energy savings, but it wasn't for aircraft. It was energy savings for buildings, So, if a wing commander upgrades a building and puts better lighting in and puts better air conditioning in or whatnot, and all of a sudden his bill is less than it was beforehand, he gets to keep some of that money. And we thought, why can't you do that for operational energy? Because operational energy is, 6 to 7 times the amount of installation energy. And so there's a big pot of money there that we could go after to help improve the way we do business. And they said, sure, we'll let you do that. And so that process behind 2912 now is, this last year we recouped about $40 million from programs that, we're tracking. Last year, at least 23, we tracked about 120 some odd million of cost avoidance because we're doing things smarter. Some of it we know more specifically, like the engine wash stuff, we know that pretty well. Yeah. The 3.5 engine upgrade on the C-130s, we know that pretty well. So we can go back and track the CPUP upgrade on the CFM or the F-108s, CFM 56s on the KC-135. We can track all that stuff pretty well. Some stuff we can't track, the impact of puckboard right now is kind of tough to track, but of those things that we can track, the way it works now is we know there's going to be unexpended O&M at the end of the year. It typically goes back to the Treasury. And we said, help us with this incentivization thing, because people will get involved if they know that there's something in it for them. If they know that there's a value to that fuel coming out the tailpipes of their aircraft, maybe they'll husband it better, and then we'll be able to come back to them with ways to solve their problems. And so that $40 million, part of it went to right back to the engine folks at Tinker, who provided us data to tell us this is how much money we save for you in fuel, and 3.5 engine upgrades and CPUP upgrades on the F-108s. And then they said, well, we have this T5 tester that we need for the T-38 engines, J85 engines. and we don't have enough of them, and we know that this will keep us from pulling engines that are not bad. They had some engine covers that they wanted us to fund. They had some stuff on the F-22 engine that they wanted us to do for them. So it worked out to be a good incentive for them to provide us the data, because they knew that we could collect the funds and come back to them and say, what else do you have? Engine coatings, are you okay with that now? If I pay for the coatings, will you allow those to go in the system so that your engines will last longer? And they're like, absolutely. Why wouldn't we do that? Engine wash, if I pay for the engine wash, will you help me facilitate the engine washes and track the engine wash data so that we can make sure that those engines are washed right when they need to be washed? It's those type of things. That incentive mechanism has turned out to be really helpful for us, not only just with the air crew as like our MEEP program, but with logisticians and maintainers, just in understanding these technologies that in the past they couldn't pay for. Like, I was out of TDY money. Well, I can pay for it now, and I can help you with your mission, because helping you with your mission means that we have more FMC aircraft that are ready to go to war.
That's awesome. That's a great resource to hear about,
Yeah.
sir, as you're talking through that. I think from like the theory of constraints portfolio that we're seeing a lot of bases and organizations that are finding ways to keep their jets in the fight longer, to keep their jets green for longer, whether this is, leveraging things that we've seen in industry. And as you talked about Delta Tech Ops, that's a place that we've gleaned a lot from them as well.
Yeah.
On the theory of constraints side, I think that is ultimately what drove theory of constraints to come onto our team and then into the Air Force, into what we know it as now. So it's kind of interesting to hear.
Yeah.
But again, a lot of these organizations are seeking that efficiency and that optimization that is resulting in greener aircraft that are staying FMC for longer, through bundling maintenance, through all these different theory of constraints tools. And I think there absolutely is some ties there.
Sure.
Into what the Operational Energy Office is getting after. And so I think for our listeners to be, if you're in those organizations too, how can we connect them, or what does that bridge look like? I think I'm kind of skipping ahead on questions here, but
I think almost every base has an innovation office, and I know they have different processes of how these ideas are delivered up. What we saw with our Mission Execution Excellence program was that we were really driving home, at least on the operational side, hey, this is why it's not so great to add an extra 10,000 pounds of fuel before you take off. We went down the path of trying to understand that problem, and I'll get into that in a little bit. But, the bottom line is that the airmen doing the job know the job better than any of us up here in the Pentagon, right? Because they're there, they deal with the challenges every day. And in the past, like me as a squadron commander, I'd just like, well, I don't know who's going to pay for that. I guess nobody's going to pay for that, so I won't even ask, right? Now, I think through Tesseract and through the innovation cells, they're starting to think through, no, there's an avenue here. There's a path here. And sometimes it's kind of tough. We felt that in the first few years in our office. We're like, hey, this fuel thing, we burn a lot more fuel than we should be burning. And it's like, yeah, no, that's fine. And then, so it takes you get bloodied a little bit, and folks, but if you stick with it, especially if you're able to tie it back to, hey, if we do these types of things, then this is going to result in us being able to maintain our aircraft better, operate our equipment better, then that will naturally lead towards these efficiencies that, as we're tracking them, we're able to go, well, we know how much that's saving us in fuel, and we can go back and incentivize it. Like on the MEEP program, it's more than just an operator program, right? So there's like agreements between operators and maintenance on standard ramp loads, and that actually makes it easier sometimes to schedule aircraft. But we also saw, and we saw this in the B-52, and then we backed it up again in the C-17, when you collect data over the years for assets that are flying way heavier than they should be, because maybe you're not as confident in the scheduling system that currently exists. Like, crews would go to base ops and they'd get a fax, and there wasn't a good way to communicate back and forth between them and the planners. At least on the mobility side, with TACC, we worked with AMC to increase that communication, because we saw it, at FedEx and UPS and everywhere else. They have a dispatcher who's basically the third person in the cockpit helping make sure they get from point A to point B. Increasing that confidence through things like Matters Most and the work that they're doing with Nightmare and other things to increase communications, increase leadership awareness of what's going on the missions that are trying to execute, gave those crews a better sense that the plan that they were given, the load that they were taking was all accurate. The route that they were doing was accurate, and if not, they would get an update so that they would be able to get from point A to point B without wasting fuel or without actually running out of fuel. And so what we saw with that was that you had a decrease in average landing weight on the order of 10 to 15,000 pounds. And then in the B-52 and the C-17, we tracked it back to, okay, let's compare an aircraft that average lands with extra fuel as compared to one that's more precisely fueled. And we saw a pretty significant difference in FMC rates. And then we started breaking it down to going, okay, why are these aircraft breaking more often? Let's look at things like, in the B-52, it was, hey, we have all this data from the Aircraft Structural Integrity Program Office on landing weights over the last 10 years. We have all this data that we have on maintenance. So let's compare those two, and this is a whale that's too big for us to bite off, but we'll get little pieces of it. Let's just look at landing gear. And we were able to see, I think it was somewhere around 7,000 maintenance man hours per year that was spent just on those aircraft that were consistently landing excessively heavy, right? So brake changes, tire changes, strut changes. We didn't even look at engines and all these other things that are tasked pretty heavily when you're operating an aircraft outside of the weight that it should be operated on. And so we think there's a lot of there in kind of talking to folks about, hey, maybe optimizing your fuel usage. Yes, it does save fuel. There's like a 3% per hour difference. You carry 10,000 pounds for 8 hours that you're not going to use. That's about 2,400 pounds of fuel. So there's a significant fuel savings there. But that other piece, nobody was really tracking. How many more parts do we have to replace per year? How many more maintenance man hours do we have to do? Because we're not flying these aircraft at the optimum weights. And so that's something that we thought was really good to focus in on because it helps everyone kind of understand the mission better and why there's a criticality of, optimum or mission execution excellence from both, what the ramp load is going to be as well as how the crew operates it so that, when the aircraft lands, it's not broke.
And on the operational side of that, right, when it's exciting to hear, and I guess this is the time now to learn these lessons, right? And to really nail down optimized fuel planning. When we start talking about agile mobility operations within the Pacific Theater, very different from how we operate now, whereas we go from point A to point B and we get gas, and then we go to point C and we get some more gas, and then we go to the next place, right? You're going to be going into a lot of austere locations with maybe semi-prepared runways that are not set up for a full fuel load C-17 full of cargo, right? And so it's going to be really crucial to have the knowledge of optimized fuel planning going into that scenario versus learning the lessons on the ground, right, or in the air or on approach. And so I just wanted to point that out. That's all I could think about while you were talking, right? Was like how important that's going to be, in a future fight, in a future fighting concept.
Yeah, and you had me thinking, Dan, too, there, that the idea of just challenging the status quo in what you were saying as well. I think that there would be an easy assumption that, a full aircraft is a good aircraft.
Right.
But then you start to see in the actual data, there's second and third order effects of, you're coming down if you're coming down heavier, then there is impacts to that, to the aircraft and the life of the aircraft.
Right.
But just being able to challenge the mindset that goes back to a full aircraft is a good aircraft and recognize maybe not.
It was funny when we initially started, talking to your crews about optimum speeds and whatnot. I started getting these photos through the reservists who were. So we had these reservists who were, for the most part, aviators who came up with these best practices, and they would go out to fly along with crews just to find out kind of what the current challenges were. And when we started focusing in on small things like that, they were like, "Hey, sir, this is great, but here's a picture of my empty C-17 because I flew this mission and I had just one flagpole, and it was actually an antenna, but it looked like a flagpole." But they're like, sir, we understand this precision flying technique and flying these, what they called mission index flying speeds, but somebody's got to help us with this part because we kind of feel like maybe we're not loading aircraft the way we could be loading them. So we started going back and looking at, hey, what's the software aspect to this? So I was a squadron commander of an AWAC squadron, right? We had 15 different crew positions. We typically had 20 to 30 people on each plane. Just the whole scheduling process required 5 flights. We had like the pilots, the navigators, flight engineers in one flight. We had the radio operators in another flight, like the radar technicians. And so that scheduling challenge was really, really tough. And it would eat up a lot of manpower. And we did it all on a whiteboard with the dry erase markers and magnets, right? Yeah. And so this whole transition that started in 2017, 18 with Jigsaw, we've really, kind of glommed onto that. So we're helping out with Jigsaw. We're providing money for Puckboard. We've done this thing called Magellan, which is more along aircraft allocation. We're looking at cargo optimization as well. There's all those things that, whether it's scheduling maintenance or scheduling air crew or allocating assets in certain locations or delivering cargo and optimizing cargo. There's so much we can take advantage of that we hadn't taken advantage of in the past that we were very comfortable with the whiteboard. Like, I tell you, I had very, very many senior people say, what if the computer dumps? We have to go back to the whiteboard. And I think the Chinese want us to think exactly that way. Yeah. We have to realize that there are certain technologies that we have to adopt. Yes, we're going to have backup plans for it, but those technologies that we adopt now will help us execute the mission more effectively and save money and be able to deliver the same amount of combat air power to the taxpayer for less money than it required beforehand, or to the advantage, now we'll be able to use the money that would have been burned out the tailpipes of our aircraft, to buy more equipment, to buy better things so that we can have better combat air power than we would have had in the past.
Yeah, that's good. Well, sir, a lot of what you talked about to me, it sounded very, very process oriented. So we were kind of going to ask about process improvement, but so many of the things that you mentioned, from the engines and identifying, what point in the engine washes, was kind of keeping them back or holding them back, I guess you could say. A lot of it just seemed very process oriented to me. So kind of flipping to a different side of things, what emerging technologies or trends do you believe have the greatest potential to transform the operational energy space in the Air Force specifically over the next 5 to 10 years or so?
So in the short term, we're getting better and better at data collection. So that helps us better understand, when the platform is not as healthy as it could be. Like one of the examples we can give you is part of the work that we were doing. The airplanes that we're flying now were designed in the 50s, 60s, 70s, and that's about, at least for the bigger aircraft that we concentrate on. Like the C-17 is basically a 70s design that was kind of modified in the 80s. KC-46 is kind of an 80s design. 135s and B-52s are pretty older than that. And nobody ever really stuck these in a digital wind tunnel and said, what does this look like? Does it fly like a Porsche, or does it fly like a Volkswagen, right? Beetle, something like that. And as we started to do that, we found that there were ways to optimize the aerodynamics. But the other thing we found is that if you pull enough data, you can start seeing when you optimize the aerodynamics, from the perfect KC-135 3D model to what this airplane is doing, you start seeing things like misrigging, or of the ailerons and, things that you wouldn't have caught otherwise. And so one of the companies that we worked with, we were doing this aft body drag reduction, these finlets in the back of the aircraft. And they were working with a commercial airline. They outfitted 10 of these aircraft with these fins. They were getting about 1 to 1.5% efficiency, which, for the airlines, and they burn a lot of fuel. That's paid for itself several times over in the first year. But they found, the company came back and said, these 7 exactly to the 1.5% you said. These, not so much, 0.7, 0.8%. So what do you think? And they went back and they looked. Those are the 3 oldest aircraft. They're out of rig. Once they optimized the rig, they got the same amount of efficiency as the other aircraft did. So for us, using that type of data to be able to go back and optimize the rigging of our aircraft, this kind of one of those uses of this big data that we're thinking about. the engine wash is another piece of that big data that we think about, or being able to identify, like the folks at Robbins. We went down to visit them, and they were using, I think they used to call it Vampire Box, right? But they're looking at the ability to pull in so much C-130 data that they can get much better understanding of the health of that system. I think that in the near term is something key for a lot of our legacy aircraft that we couldn't do beforehand that we can do now. For operational energy, big things. So like one of our big things is the blended wing body aircraft. We heard about that technology, and we started looking at how well our legacy tankers will perform in the Pacific and how much better these blended wing body assets could perform. The project had kind of stalled at NASA. They had done what they had done, but nobody ever took it to like full scale to see. And we're in the process of doing that right now. The plan is to fly the full scale blended wing body by 2027. And we think with a public-private partnership aspect that we have of it, the airlines will find something interesting, as well as we could potentially find something interesting as well that will lower our development costs, as opposed to having a unique platform that we only pay for. We might be able to leverage what private industry is doing to have maybe a cargo plane or an arsenal plane or a BWB, or an air refueling plane that is much more efficient, on the order of as we understand it now, about 6 to 7 F-35s as compared to 1 in the KC-46. So a pretty big, at 4,000 miles, a pretty big increase in capability of being able to deliver fuel, which we think is going to be critical in the Pacific, as per the discussion I had earlier about the distances and all. So that's kind of like our exciting thing. And we think a lot about it similar to the Boeing 707 was initially the Dash 80, right? You can see it over at Dulles here. You can go over to Air and Space Smithsonian at Dulles, and you can see the original 707 platform. And it really didn't take off until Boeing had their prototype flying. And then Tex Johnson did a barrel roll over Seattle, and kind of made everybody believe, yeah, this is possible. And the next thing you know, Juan Tripp from Pan Am is ordering 707s. Curtis LeMay from the Air Force is ordering tankered 707 variants. So we think that that's really kind of the wave of the future. I mean, you can do a lot of stuff with AI and other things to optimize processes, but at some point, physics is going to be physics, right? And aerodynamics is going to be aerodynamics, and you're only going to be able to deliver so much cargo if you look at optimizing the aerodynamics of the plane. Cargo or fuel or whatever our needs are. So that's our big project right now, and it's going pretty well. And we go out there to Jet Zero and visit them and Scale Composites pretty often, because they've got a great product. So
that's awesome. I'm excited. I'm a bit of an airplane nerd. Everybody at the office knows that, but it's probably not a good spot to sit. But right at Andrews, at my desk, I just have a view of the flight line, right? Yeah. And so every time an airplane takes off, especially a C-17 being a crew chief myself, whatever we're doing, pause, let's watch the plane. Okay, cool, and we'll go back to what we're doing. But yeah, it's really exciting to hear about technology that turns our current thinking of aircraft structures on its head, right? Right. And we. We're always excited. We're the most advanced Air Force in the world, right? And nobody can take that title from us. And it's because of initiatives like this, getting ahead of the game, and just thinking outside of the box constantly.
Yeah. And that's what you all are doing. Is you're saying, hey, we know that there are challenges. We're up here at the headquarters now. How do we get a group together to help energize airmen and energize their thoughts? Because they're going to know what the true challenges are. And solve those problems that they see right now that in the past probably didn't make it up here, didn't get recognized.
Absolutely, yeah. Mm-hmm. We're going to roll into some rapid fire questions,
okay.
But and then maybe we'll have a little bit of time afterwards. This will be. I'm sure you've heard the analogy here, the swivel chairing, right? Multitasking.
Yeah.
But this will be the ultimate swivel chair challenge. Well, we'll bounce back and forth with questions. So,
all right.
First question: if you were an Avenger, what Avenger would you be?
Oh, man, I am just like so. Oh boy. Can you give me some examples of the current event? You know?
Yeah, I mean, I always pick Iron Man.
Right.
You know, there's the Hulk. If you
The Iron Man one, I think I'll go with that one.
There you go.
Classic.
That's right.
Yeah.
Yeah.
Okay, your favorite musical instrument?
That's guitar.
Guitar.
Okay. Do you play the guitar?
I do. Yeah, I have an old
Awesome.
acoustic guitar that I like to break out every once in a while. Yeah.
Awesome. I've had 3 in my life. I just bought another one, and I hope to learn here in the coming months.
I think we all go through a phase. I recently had a guitar as well. It was like one of those COVID things.
Yeah.
I will learn, and then eventually I gave it away to somebody.
It's awesome. iPhone or Android?
iPhone.
iPhone. Okay. Copy.
Fun.
Is it because of the text bubbles? Is it you?
Yeah, you know, we had a joke. A friend of mine. I've been like an Apple nerd for years and years, and I was always trying to convince him. And now he's bought an Apple, so I don't have to convince him anymore.
Nice.
He was like, a friend of mine used to say these are really fast. I go, all right.
Still trying to convince my husband to make the jump. Star Trek or Star Wars?
Wow, that's a tough one because I think I have to go to my roots. You know, we used to watch Star Trek reruns, my mom and my dad. My mom would always come in halfway through, right? And she would say, I don't think I've seen this one before. We're like, Mom, we've seen these a million times. But yeah, Star Trek.
Awesome. So you're going on a family vacation. Where are you going?
Oh, I think Kauai. Yeah. Yeah, we honeymooned out there when my wife and I were newly married. Barking Sands Naval Air Station. And it's beautiful out in Kauai, so we went there.
Awesome.
Awesome. Do you have a favorite Star Trek movie
Oh,
of all of them?
yeah, the Wrath of Khan, I think, is probably the best one. Yeah,
Okay.
The second one was pretty good.
Okay.
And you know, Ricardo Montalban, that was him. He didn't have any prosthetics or nothing like that. That guy, he was old guy, and he was still pretty buffed. So yeah, it's pretty cool.
Aspirations.
Yeah.
right? Maybe someday
Yeah.
when I retire. Yeah.
Yeah. It's on my vision board, a picture. Yeah. We added this question specifically for you. Gas, diesel, or EV?
Oh wow, that's tough. So, boy, you know, hybrid.
Okay.
I kind of think, at least for the near future, hybrids are probably going to be still pretty dominant. You know, and there's some cool hybrids. I have this cabin in northern New Mexico, and we could make it to the nearest place to get food and stuff like that if it was like a decent like EV that had just a little bit, you know, like hybrid EV, you know, pluggable EV. So we'll see.
Okay.
Awesome.
And then lastly, what would your superpower be?
Man, what's my superpower? I think it's taken me a little while, though. You know, I'm not as, you know, I think one thing I like to do, and it's just acknowledging the fact that we in our office don't know everything. You know, we actually know very little as compared to what's out there, and that we have a strategy, and we develop that strategy based off of what we know, but we're open to changing that strategy. You got to change it. You're not going to know everything, right? And people are going to be able to, and if you're able to, accept the fact that although, like, you know, I've got 3 daughters, and you know, when kids are small, they're the prettiest baby in the world, right? You know, and you got to be able to accept the fact that not everything's going to be perfect, and whatever you're like the BWB or, you know, the MEAT program or something, it's not all perfect, and you got to be comfortable with people telling you this is what I would tweak to make it a little bit better. You know, and if you can do that, then you get this continuous improvement of the product to adapt to whatever's going on. And so, you know, I think that's one thing that, you know, we're nothing's ever so precious in what we do that we can't tweak it to make it even a little bit better. So.
That's great.
Yeah, it's definitely a great answer. And you know, if you wait around until your plan is perfect, you're never going to take action, right? And we don't have time to not take action.
Yeah,
so
90% is good enough, right?
Yeah. That about wraps it up, but I wanted to give you an opportunity. You know, a lot of our listeners are younger airmen out in the field, right? And young maintenance and logistics officers across the Air Force. Just to, you know, leave them with a little nugget or a charge or, you know, something to leave the podcast with.
The oxen are slow, but the earth is patient. No, I'm joking. I love that quote, but it's not. Sorry, I love that quote, but it's not what really is to don't get discouraged by, if your idea isn't immediately adopted, if it's a good idea, keep bringing it up, because you have to be somewhat persistent. Like General Finley was the vice commander of AMC, and he points to me, because I've been in this job a lot longer than you would typically be in a job as an SES. But he talks about how, I've been pretty persistent over these years, and we've seen only in the past 5 years or so that we've really started to make some headway in, getting our program the way it needs to be, as well as, getting that program actually achieving results. And so, sometimes folks will suggest something, they know it's right, and somebody will shoot them down and they'll stop. And I would just say, we know you have great ideas, and you have to be persistent in sticking with that, because, the only constant is change, and we need to be able to adopt change. We need to be able to hear from you and your great ideas.
Awesome. And if you're a listener and you're the one that has a great idea and you're being told that it's not a great idea, give us a call. We're here to help.
Yeah, that's great.
Awesome.
Absolutely.
Well, thank you for joining us today, sir. We really appreciate it.
Yeah, thank you.
My pleasure. Yeah, thank you.
Any references to trademarked, copyrighted, or protected products or services, such as books, movies, or businesses, are used here for the limited purposes of educational and professional development of Air Force Airmen. If you have any questions, please contact us at www.tesseract.af.mil. God, I messed it up at the end.